All right, we're going to be doing a video to show how to make a workspace in EMSE and then process some heart rate data. Opening up EMSE here. I'm going to go to File. I'm going to make New Workspace. This little star here means that it's not saved, and these titles are done by default. So we're going to change that by going to File and do Save Workspace As. I already have it set up so that it's going to go to this folder that I made for follow-up physio data, but you can just follow this like you would any other save as type of window. Calling it follow-up heart rate. I'm going to save it here. So for when EMSE says project, what they mean is file. So it says individual participant. So I'm going to right click on this and rename it to 103 for participant 103. If I want to make a new project, I can right click on the workspace name up here, and I'll do new project. And let's do 111. It's another participant that we have. The one thing to know is that EMSE is not going to have any way of sorting this by numeric order. So if I make a new project and it's 221, and then I make a new project that's 130, that's the order that they're going to appear. So normally, because I'm processing this as the data comes in, these are out of order, which is a little bit annoying, but it still gets the job done. So you'll see here that this star means that it's not been saved, and that's because I've added I've added some new projects here. So I'll go ahead and save it again. Okay. Now, what I like to do is to have a folder set up that's going to have everything related to this particular chunk of data. So we have the workspace file here, and then we have all these folders for participants that have follow-up data so far. That's 103 through 339. So eventually this is going to have, several hundred folders. And in each one of these at the beginning is just, should be just a PDF file. There's some other things here because I did some stuff before, but normally it will look just like this when you open up a file initially. All right, now how do we get this data into EMSE? So I'm going to go to 103 and I'm going to right click and then go down to add time series data. Again, it's going to open up these windows. I'll go to 103 since that's the ID for the project that I'm working on. I'll go ahead and click that. And when you're opening up somebody for the first time, it's different than on subsequent times. So this is pretty important to do correctly when loading a file initially. I'm going to click, and this dialog is going to pop up. Basically, the thing to know here is that we want to uncheck this box and press no. What it's trying to do is to say that we haven't told the program what kind of data this is, and it's trying to figure that out by using some defaults, and we actually don't want to do that for heart rate data, so we're just going to say no. It's loading the data here. This is everything that's the EEG channels, but we can see more. So if we go over to this thing that says 32, that's showing us the 32 channels from the CAP, but we can say, let's show us all 47 channels of stuff that you've got recorded. And now you're going to see over here, we've got the different, we've got the mastoids, the eye channels, the heart rate channel for EXG7, skin conductance, respiration, all kinds of good stuff. Now, not all of these have useful information in it, and we're actually going to turn most of this stuff off to make it easier to see what we're doing because this isn't scaled in a way that's at all useful. So what I'm going to do here, I'm going to go to Edit, and I'm going to go to Channels. Everything is set to on right now, and I want to turn them all off. And then I'm going to go just to EXG7, which is our heart rate channel, and turn just that one on using these buttons here. See, everything else is off except for that one. And I'm going to hit Apply. It's a big change to the screen, and that's good because we want to be able to see things clearly. Press OK. So actually, there's an easier way to view this data. It's not in the chart recorder mode, but in what's called superimposed, and we're going to look at that. I like superimpose because it's going to tell you the time course very clearly down here, and also the units are just easier to see. It's got the name of the channel up here just so we can keep track, but for the heart rate, it's pretty clear because it's just going to be the one channel. Next thing I want to do is go to um, filter this data a little bit. So you can see the R peaks really, really nicely, but you'll notice that they're kind of moving a little bit across time. So like sometimes they're higher, sometimes they're lower, and we can get rid of that by doing some filtering. So there's a couple ways to get to that. It's called the filter pipeline. You can go to analysis and filter pipeline, or you can just click on this little triangle here. It's the same dialog either way. So by default, there are a couple things that are grayed out. You don't have to worry about that. But we want to add a filter. So we can go to add. We want digital IIR filter. I double click that. So there's only one channel that it's seeing right now because I turned all the others off. We want to do a band pass filter. And the numbers that we've picked are 20 and 2. Now, the actual values themselves don't matter all that much. What matters is that you do the same filters, a bandpass 20 high, 2 low, Hertz filter for all participants. As long as you're using the same thing, then you are in good shape. We're going to press OK, and we're going to press OK on this main menu here. And then you're going to see a change on the screen again. Much, much nicer. Everything is kind of centered almost, and it's just a little bit cleaner. When we're actually going to be processing the heart rate data, we're going to change the units down here. Sometimes we'll change the units on the y-axis also, but we're definitely going to change the units on the x-axis because we're looking at too many heart rates. Right? There's too many beats on screen to really be able to tell exactly what's going on. So now we see there's 4 on the screen right now. Now there's 3. It is much easier to tell what's going on. So here we have this is the beginning of the QRS complex. This is the peak. This is the T peak. And this is really one sort of heartbeat right here. And we're really interested in the peaks. So that's what we want to know so far. At this point, I'm going to go ahead and save the data, save the workspace. Now, I've been keeping track of some different measurements that we're going to take in a Google Sheet. So I'm going to go ahead and open that up. I haven't actually set this up for time 2 yet, so I'm going to go ahead and pause the video and set that up, and then we'll continue. Okay, so I've gone ahead here and made this heart rate sheet on the Google Sheet here for us to keep track of some different things that we're going to measure. I have a column for quality. I have a column for measuring the R peak. We're going to want the R peak half height, which is going to be in this section. We have another column for the full width of the R peak at the half max height value, and that's going to be in milliseconds. We're going to measure the time from the R peak to the T peak, and then we're going to set a refractory period, which is really important because basically what we want to make sure is that EMSE isn't going to, by accident, count T peaks as R peaks. And all these values are going to be for the algorithm that EMSE is going to use to count the number of, to count and mark the number of R peaks that are occurring. So let's go back to EMSE for a minute. Okay, so here we can put the cursor over the top of the R peak, and in the bottom of this menu right over here, it's going to say cursor location. And it's going to give you the time and the unit for the height in volts there. So that's that number with its 0.000069. But you can also sort of eyeball it from looking at the y-axis over here that this peak is pretty close to that hash mark, which is 0.7. I think this is millivolts, 0.7 millivolts. So I'm going to go ahead and put zero point 0.7 into um, that Google sheet. But you can tell that this is just like one example. So this one is going to be much higher than that. This one is closer to zero point 0.6. And this doesn't really matter. And you'll see why it doesn't really matter so much in a little bit. So the R peak is zero point 0.7, we're going to say. And we'll just make a quick little formula to do this and divide it by 2 because we want the half height. So 0.35. Now we're going to go back to EMSE and we're going to put our cursor around 0.35. And again, I can see where the cursor is by looking at the bottom left. This doesn't have to be exact. I'm going to click here and drag my mouse over. And now you can see at the bottom left, it says something called selection range, 0.025 seconds. And this is the width of the R peak at the half height because I started where at 0.3 at 0.35 microvolts here, or millivolts, sorry, 0.35 millivolts, and measured across from here to here. And the value that we get is 0.025 seconds. And I'm going to go put that down here. And the reason why we're keeping track of all these is one, it's too many numbers for my brain to be able to keep track of, but also, in theory, if something went horribly wrong with the data, we could go back and look at this and use these same numbers and they would get the same results. If we needed to reprocess this data, we could save ourselves the step of having to measure all these things again by just taking these values here. Okay, so the next thing is the R peak to the T peak. Okay, and so I said before that this is the T peak, this is the R peak. So we'll put the cursor towards the R peak. We'll go over to T peak. Again, this doesn't have to be exact. This 103, it's very easy to see. Sometimes this is harder to see exactly where these are. That's okay. So again, we can hover over this and we can see the range is 0.24 seconds. That's pretty typical. You get anything from 0.19 to 0.27 in our participants. So 0.24 is pretty normal. I'll go ahead and record that here. And so we want to pick a number for the refractory period that's not going to accidentally grab those T peaks. So if make a new selection, you want to get from the R peak well past the T peak. And so you see that if we say refractory period of 0.36 seconds, basically what that's going to tell the algorithm to do is if you count an R peak, don't count another one until at least 0.36 seconds have elapsed. That's what the refractory period is referring to. So we probably could pick something even shorter, something more like 0.31. Um, but to be on the safe side, I like to pick a number that's a little bit higher. And if you look at it, we're not even close to being in danger of having the refractory period be so long that it won't count the next R peak. So as long as we're not, doing something crazy like having a refractory period of zero point 0.8 seconds, we're going to be fine. So I'll pick something that's well past the T peak. So 0.38 looks very safe. And we'll go ahead and put that number down. We don't actually use all these numbers in the algorithm. You'll see which ones we use right here. So now we're ready. We've done all of our measures. We're ready to go ahead and open up the algorithm. So we're going to go down to Edit, Events, and Trigger Search. That's just the name of the dialog to pull up the algorithm. Again, we only have this one channel. We're going to highlight the channel that we want to use. We're going to click ECG, and that's telling it, this is the kind of trigger we want you. This is the kind of algorithm we'd like you to use here. And then we go to settings. This is where we're going to put in those numbers. So this is the FWHM, is the full width at half height. And I don't remember. It was 0.025 seconds. 0.025. Then the peak threshold, we don't actually use the full height. We're going to use that half height value because what that's going to do is it's going to make sure that we capture are peaks that are a little bit shorter, which is good because we don't want to miss any. So let's see. We said that was 0.35. So that's a little bit dangerous because you can see that like this T peak is probably pretty close to 0.35. But because we have the refractory period, we probably won't capture this by accident. So we should be safe. And we said that it was about 0.38 was a good refractory period. So go ahead and put that in here. And then you want to name these peaks. We're going to call them R peaks. And we're going to press OK. And now we're good to run it. We're going to press OK. And you'll notice that this box pops up. It'll say 2,381 triggers have been detected. This is going to be a number that's different for all people. And when you close this, you can't get back to this number. So I like to make sure I look at this and then write it down right away. So it's 2381. And I put that over here, 2381. That's the total number of R peak served, the total number of beats that we recorded from this person during um, their completion of the tasks. So we'll go ahead and press OK, and then this dialog can go away. And now you see that there are these new blue lines that have popped up, and they've got R's listed at the top, which is what we told it to do. So you can see just from looking at the slice of data that we're in good shape because here we have the R peak, and it is not counting the T's, which is exactly what we want. So if we're being really thorough, we should zoom out a bit and check through this file. So you can see we're not getting any of these T peaks, which is excellent. We're just getting these R's, which is what we want to do. Now, sometimes at the beginning of a file, especially if the person who is doing the EEG collection put the heart rate channel on last and pressed record, it might not have had a chance to settle down yet. And so normally you're going to be missing R's. If you miss any, you'll miss them at the beginning. But this person has such clear data and it's so clean that you're really not in danger of that issue um, at all. So we're not having any problems here. No T peaks are being counted by accident, which is awesome. And we'll go look towards the end just because I don't want to take up too much time. So again, even here, look, this is a good point to show, which is that these two R's are a little bit further away from each other than is typical for this person, but it doesn't matter. It's not capturing the T's by accident. Sometimes it takes the program half a minute to put the R's on there, but they're there even if they don't pop up right away. Yeah, see that? Awesome. So really, really, really solid. This is a bit strange right here, but I wouldn't be too worried about that. So I think this looks great. We don't need to save these kinds of things. These things are sort of done behind the scenes. They're generating files, but when I try to close this, it's going to ask me to save it, the file that's been generated behind the scenes. So go ahead and click X. It's saying event list has been modified. When it says event list, it's calling the R peaks. Those are called events, and we want to save those. So I'm going to go ahead and press yes. This dialog box will come up. I never want to mess with this. I just do with it's you want to save over the file here, and you press yes. Now this is not changing the data in any way, shape, or form. This is not like a reversible decision. So you should feel totally comfortable saving this over. And in fact, that's the right thing to do. Okay, now that's all you need to do for processing an individual person. We haven't made any additional rules beyond that. In theory, we can, but I don't know if we're going to actually do that. And then you're done with this person. If you wanted to go look at their data again, you can just click on ARCS 103 to pull it up, and there you see where we left off before. But we're really done with 103, and then you can go on to the next person. But of course, there's more steps that need to be done once you have several people processed, and we'll make a video about that shortly.